In the circuit shown, the ammeter reads 2 ampere. What that means is the current in the 5 ohm resistor is 2 ampere. Find the current in the 7 ohm and the 2 ohm and the EMF of this second cell. If you cannot read this, the EMF of the top cell is 15 volt. Alright, how do we start this? So we start by naming the points so that we can choose our loop either clockwise or counterclockwise. This is point A, this is point B, this is point C, point D, I don't think you can see that, point E, point F. Okay. Now, I1 is the current. Now, you can actually assign the direction of current in any arbitrary direction. It really doesn't make any difference. The method of the problem will correct you if a current that you assigned is in the wrong direction. Okay, so don't worry about that. You can say I2 is the current, well, I1 is the current in the 7 ohm, that is, this 15 volt sends a current through 7 ohm, it comes to A, and the cell of EMF E sends a current. Remember, the current always starts from the positive of the battery and ends in the negative. So you can assume like this, a current from this battery flows like this, reaches A. A current from this battery also flows like this and reaches A. And those two will now combine and go through the 5 ohm and through the ammeter, comes to D and splits and goes their different ways. So let's start assuming that I1 is the current through the 7 ohm and I3 is the current through the 5 ohm. Well, I2 is the current through the 2 ohm and I3 is the current through the 5 ohm. Well, the current through the 5 ohm we know is 2 ampere, it is given. So the assumption that we started with, let this battery drive a current I1 into 7 ohm and this battery drive a current I2 in the 2 ohm. I1 and I2 will come to junction A. They will join and go as I3 in the 5 ohm. They will join at D, then split as I1 and I2. Okay. I1 and I2 reach the junction A and I3 leaves that junction. Alright, give me an equation connecting I1, I2 and I3. I1 is reaching A, I2 is reaching A, I3 is leaving A. Therefore, we can write I1 plus I2 minus I3 equal to 0. Is that right? I1 reaches A, that is positive. I2 reaches A, that is positive. I3 leaves A, that is negative. Algebraic sum of the current meeting at a point is 0. We got one equation. I1 plus I2 equal to 2 because I3 equal to 2. I took it to the other side. I1 plus I2 equal to 2. This is going to be much simpler than the one we did earlier. Applying the second law to the closed circuit ADCBA. Let's do that. ADCBA. Alright. Can you apply that rule and give me an equation? If you notice, ADCBA VBA, the direction of the loop and the direction of I3 are the same. The direction of the loop and the direction of I1 also the same. That means the potential drop across the 5 ohm and the potential drop across the 7 ohm are both positive, because the direction of current in those resistors is the same as the direction of tracing of the loop. But the loop is traced out, you see that? ADCB, it traced out from the negative to positive of the cell. The potential drop across the cell is negative. So what's the equation? 7I1 plus 5I3 minus 15 equal to 0. 7I1 plus 5I3 minus 15 equal to 0, or we rewrite it as 7I1 plus 5I3 equal to 15. We got two equations. Well, we cannot solve these because the first equation contains I1 and I2. The second equation contains I1 and I3. We now have to look for another equation. Which loop will you consider? You can do this on your own now. Okay, I have picked the two equations there. But, you know, you can right away solve equation 2. You know how? Because you know the value of I3. We have been told that I3, the current in the ammeter, is 2 ampere. So use I3 equal to 2 ampere there. We have 7I1 plus 5 times 2, 10 equal to 15. And solving for I1 gives me I1 is 0.71 ampere. If you now know I1, you can go and solve for I2. So I1 plus I2 equal to 2. Therefore, 0.71 plus I2 equal to 2, or I2 equal to 1.29. That was a very simple problem, because one of the currents was given to you. Well, apply the second law to the closed. Well, we haven't finished, have we? No, we need to find the EMF E of this cell. So that can be obtained by applying the law to this closed loop. What is the one? ADEFA. Now look at the way I have taken the loop this time. This time I have taken the loop in the clockwise direction. Can you tell me why I did that? Because the current I3 and the current I2 are both in that same direction. That is why I now took ADEFA. You can choose the direction of the loop on your own. Alright, if you now take this loop, tell me what is the potential drop across the 5 ohm now? The direction of the current is the same as the direction of the loop. Therefore, the potential drop across the 5 ohm is 5 times I3. We know I3. And the potential drop across the 2 ohm is 2 times I2. And what is the potential drop across the cell? The loop ADEFA is traced out from negative to the positive of the cell. Therefore, the potential drop across the cell is negative. Alright, so we can write 5I3 plus 2I2 minus E equal to 0. That is the equation from that loop. And we know I2 and I3, therefore we can calculate E. Using the value of I2 and I3, we get E equal to 12.58 volt. Okay, let's do another one. In the